So in this video, we're gonna look at our first subset under obtained regression model called the estimated regression sample model, estimated regression equation, or estimated regression model. So basically, we try to obtain this model, y hat equal to b0 plus b1x plus b2x2. So the method we're using is very similar as a simple linear regression model. It is called the least square criterion. Basically, our objective will be finding the value of b0, b1, b2, etc., such that it can minimize the differences between the real y value and estimated y value. So that's our criterion. So keep in mind, it might be showing your quizzes. And so instead of using the hand, and actually we won't be able to use hand to do the calculation for this complicated multiple regression equation because it's involving the matrix algebra. However, we do have the Excel. The Excel will help us to finalize our final answers. And so now let's look at an example together, and then we will be able to learn how we get how to write down our regression analysis. And so as we're watching this example, and I hope you can get this handout ready called Chapter 15 handout. IMP stands for important because you're going to rely on this handout to help you on your homework and also your attendance check. So look at this case. So the owner of the large chain of the health spas has selected 8 of her smaller clubs for a test in which she varied the size of the newspaper ads and the amount of the initiation fee discount to see how this might affect the number of the prospective members who visited each club during the following week. So after you reading this problem, so how many variables can you identify? Yes, 3 variables. First, you notice that the first variable will be the prospective members, right? The prospective members. And then the second variable is the size of the newspaper ads. And the third variable will be the initiation fee discount, so the discount fee. So the question is, like our first step, you have to understand which variable is your x variable, which one is your y variable. So look at these 3 variables, which one is your y? And which are your x variables. So keep in mind, so the y variable is called the predictive variable. So you're using x variable to predict the y. So therefore, for the owner itself, they care about how many new members they can generate by using these 2 marketing strategies. So therefore, the prospective new member will be your y variable because that's the one the owner want to predict after they implement these 2 marketing strategies. So she doesn't need to predict that the newspaper ads or the discount fee because she's the one to decide these 2 values, the 2 variables values. So therefore, the size of newspaper ads will be one of x, and then the initiation fee discount will be another x. So therefore, in this case, it's different from what we see in chapter 14. Instead of one predictor, one x variable, we actually has 2 x variables. So let's look at the data together. And so in this case, the new visitor y variable is in the second column, and we have 2 predictors. X1 is at the column inches, and X2 is the discount amount. So totally we have 8 clubs. So that's why you see there is 8 rows. And so after this, we talk about this video, and you should watch the computer skill 5. And in computer skill 5, you will be able to look at how we're gonna generate regression output for this case. But like I said, for this video, we're going to focus on how to read the Excel output. So Excel output. But if regarding how to getting our regression output, please watch the computer skill 5. So after we identify my y and x variables, let me write down my population model. So y equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus arrow term. And so we have x1 representing the size of the ads. X2 is representing the discount amount. So before I move on to the handout, and I want to ask you, what's the name for beta 0? Yes, y-intercept. How about beta 1? So how about beta 1? Yes. So beta 1 is what we just said, partial coefficient of x1, right? But we know the name of x1 here. So the x1 is x, the size of x, right? The size of the x. So the x2 will, the beta 2 will be partial coefficient of discount, right? In this case. So that is how we find the name, how we name the betas. So later we're actually going to use it for our interpretation. That's why I emphasize it again. So then we're going to use the computer software help us to figure out what's the value estimated regression equation. So that's why I said back to using our equation, the handout I give you. Look at page number 1 of chapter 14 handout, or chapter 15 handout. And you should download from this week's module. And so you notice that in page 1, there is 3 tables. Look very familiar to you too, right? So basically the setup of this outcome is very, very similar as what we saw in chapter 14. So that's why I mentioned at the beginning of the chapter 15, 14, 15, they are very similar. Not only just because the analysis step will be exactly the same, but also the outcome from Excel will look very similar as well. So what is the difference? What is the main difference? So the last table, table number 3, have actual 1 rows. Before, if you go back to look at chapter 14's handout, so the last table totally have 3 rows, but now we totally have 4 rows. So the first row is the labels, okay? And so the reason we have this actual 1 more row, it is because we have 2 x variables instead of just 1. So if you go back to look at chapter 14's handout, if you take note, and you will notice that the coefficient column is where you'll find the value for b's. So the coefficient for intercept, so this one will be your b0, and obviously the one under will be b1. So that is a partial coefficient for the ads, right? We just write down on the paper. And the last one will be the partial coefficient for discount amount, beta 2, b2. So now we have b0, b1, and b2. In order to obtain the regression equation, so we just need to replace our b's value in the regression equation with the value we obtain from Excel files. So that's why you have 10.687 is your B0 plus 2.157, that's your B1, and then plus 0.042, so that is your B2, right? So this is how we obtain our the regression outcomes, regression models. And so you can write it down. And so the next question before we move on, ending the video and talking about the Tencent chat question, and I want you to think about, remember at the beginning I said, in this class, we not only just try to get a number right, but also we try to interpret result, because after you find a job, you might notice that your boss might have no idea about the regression outcomes, but they will have business sense. So then you have to interpret the result so that it can meet their needs. So now you have this equation. What is this 2.157 means? So what is this 0.042 means? And so think about it. And so we're gonna look at an interpretation formula together. Okay, so in order to guide you to think about this problem, so think about, let's assume this is a simple linear regression model. Let's just delete x2. And so in the previous chapter 14, you learned that, so this slope, if we treat it as a simple linear regression model, and then we covers up this last pair of the beta and the x, b and x. So when I look at this, how should we interpret 2.157? So how should we interpret it? So that is x1 increased by 1 unit, and y will change by 2.157 unit. But we do know what's the meaning for x1 and x2. So that's why x1 is my added column inches, and the y is the number of new members. So that means if we increase the ads by 1 inch, we are expecting to have 2 more new members, right? 2 more new members. However, we do have this x2 involved, so beta b2 x2 involved. So how can we how should we consider this actual component as we're interpreting the result? So the answer is pretty simple. What we're going to do is when we interpret the one partial coefficient, we are treated as a simple linear regression model. And after you interpret it, just need to add one more extra phrase, that is keep other variable not change. So basically this partial coefficient is measuring x1 change, how y will respond given your x2 is not changing. So if x2 change as well, so this shouldn't be the value obtained. So that is the actual one thing you need to add in comparing the chapter 14. So the interpretation are are the same, almost the same, except at the end of your interpretation should add one more phrase, that is keep other variable as constant or keep other variable not change. So let's look at our interpretation formula. And so BI, so the I representing B1, B2, etc. One of the B, except B0, represent an estimator of the change in Y corresponding to a 1 unit increase in Xi when all other independent variables are held constant. So this is the only difference between simple and multiple linear regression model. That is, you need to add this actual phrase called when all other independent variables are held constant. So if this is a test or homework, if you're missing this phrase, and you're definitely going to lose point because this is the difference between simple and multiple linear regression model. So let's look at the answer for this case. So B1 2.57. For each column inch of ads she buys, she can expect an average of 2.157 new members when discount fee is held constant. Again, the last phrase is distinguish this multiple linear regression model from simple linear regression model. You can see the first part of the interpretation is literally is a simple linear regression model. And however, after we add in the last phrase, it indicates this is a multiple linear regression model. So how about B2? Before I show the answer, think about B2, which is 0.042. So which means if the discount amount increased by $1, so the number of new members will increase by 0.042, given the add column interest is not changed. So the question I want to ask you, does that make sense to you? So if I'm your boss, you told me like that. So $1 increase only increase 0.042. Basically means it's not even a 1 people. So you cannot say 0.042 people. So nobody know that, nobody agree with you. You can call a person a 0.042 people mean anything. So how can we adjust our interpretation so that make our interpretation make sense for people who have no idea about statistics? So think about increase $1 in discount amount, increase 0.042. How about an increase $10? So basically, if I increase $10, so this partial coefficient will increase by 10 as well. So for additional $10, and so your customer will increase by 0.42. Still doesn't make sense. How about $100? Yes, that makes sense now, right? If you increase the discount account amount by $100, basically this partial coefficient is multiplied by 100 as well. So we'll increase by 44.2 new members. So approximately 4 members. So let's look at the answer for part B. So for each $100 she allows in members discount, she can expect an average of the 4.2 new members given the amount of ads does not change. So this is the answer of the interpretation.